everyone. Today we are going to solve class 10th maths unit 1st real numbers for CBSE board. Class 10th maths unit 1st real number. First of all, we have to know about real numbers. What are real numbers? How do we define real numbers? Real numbers can be defined as the union of both rational and irrational numbers. Means the numbers which include both rational as well as irrational numbers are known as real numbers. They can be both positive or negative. They have a positive value as well as negative values. Usually denoted by symbol R. The symbol used for real number is R. We are discussing about rational and irrational numbers. Rational numbers. A number is rational if it can be expressed as a fraction. Means the number which can be expressed as p by q form, then they are rational numbers. For example, 1 by 9. 1 by 9 is in p by q form, that is in fraction. It includes positive and negative number including 0. Means here number can be positive, that is positive 7, as well as negative, that is negative 6. And also 0 by 3, 0 by 7, negative 4 by 9, 7 by 11, etc. All these numbers are rational numbers except 1 by 0. The number where q is equals to 0 are not rational numbers. We are discussing about irrational numbers. Irrational numbers cannot be expressed as a simple fraction. Means the number which cannot be expressed as p by q form. Then they are irrational numbers. When written as a decimal, when we write in the decimal form, then the number are non-recurring. Non-recurring means non-repeating and non-terminate. There are two conditions for representing irrational number in decimal form, that is non-repeating and non-terminating. Here 2.6173, not any digit repeat here, so it is a irrational number. Similar for the pi, that is 3.14 and it is non-terminating. So it is also a irrational number. What are natural numbers? A natural number is defined as a counting number. It starts from 1 onwards. They are represented at the right side of the number line after 0. Means the numbers which we can count, that is 1, 2, 3, 4 and etc. are all natural numbers and they are represented on a number line after the 0, that is 1, 2, 3, 4 and so on. All these numbers are natural and they start from the 1. 0 is not a natural number. Next, whole number. What are whole numbers? A whole number is a collection of 0 and natural numbers. Means when 0 is included with the natural numbers, then they are known as whole numbers. They are represented at the right side of a number line. They are also represented on the right side of a number line. We are discussing what are integers and composite numbers. First of all, integers. What are integers? They are defined as the collective result of whole numbers and negative of all natural numbers. As we discussed already, that whole numbers are 0, 1, 2, 3 and so on. Negative 1, negative 2, negative 3. All these numbers, that is positive number, 0 and all the negative numbers are all integers. Example, negative infinity, that is negative 4, negative 3, negative 2, negative 1, 0, positive 1, positive 2, positive 3, positive 4 and to the positive infinity are all integers. Next, composite numbers. A composite number is defined as a number that has more than 2 factors, meaning it can be divided by 1, the number itself, and also by some other number. For example, number 14, factor are 1, 7 and 14. So 14 is a composite number because it is divisible by 1, divisible by 2, divisible by 7 and also divisible itself, that is by 14. So it is a composite number because it has more than 2 factors. Similar to this 18. 18 is also a composite number because it is divisible by 1, 2, 3, 6, 9. So the composite numbers, the numbers which have more than 2 factors are all composite number. Integers. Integers are the number which include negative, 0 as well as positive numbers. So we can classify integer as positive integer, 0 and negative integers. Let us discuss what are prime and co-prime numbers. A prime number is defined as a number that has only two factors. Two factors include, out of these two factors, one factor is the number 1, and any two prime numbers having at least one common factor are known as co-prime number. So, prime numbers are the numbers which have only two factors, that is the number 1 as well as the number itself. For example, 3. 3 is a prime number because its factor 1 as well as 3. Next, 5 is also a prime number because its factor is 1 and the number itself, that is 5. Similar to this, 7. 7 is also a prime number, that is 1 and the 7 itself. Co-prime numbers, then two numbers which have only one common factor, then they are known as co-prime number. For example, here 3, 5 and 7 are co-prime numbers. Here 3, 5 are co-prime because they have the common factor, that is 1. Similarly, 5 and 7 are also co-prime numbers because they have the common factor, that is 1 only. So the two numbers which have only 1 as a common factor, then they are co-prime numbers, and the numbers which have only two possible factors, that is the number 1 and the number itself, then they are prime numbers. For example, number like 3, 5, 7, 11 are prime numbers and their factors are 1 and the number itself. So they are prime numbers. There is a theorem, that is fundamental theorem of arithmetic. What is this theorem? Every composite number can be expressed or factorized as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. Every composite number can be expressed as a product of prime numbers, and these prime numbers are unique for each composite numbers. For example, 2520 can be factorized as 2 multiply 2 multiply 2 multiply 3 multiply 3 multiply 5 and multiply 7. When we multiply all these numbers, then we get back 2520. We can factorize also 12. That is 12 divisible by 2, we get 6. 6 divisible by 2, we get 3. 3 divisible by 3, we get 1. So here factors for 12 is 2 multiply 2 and multiply 3. We can express this composite number as the product of the prime number. NCERT exercise. In new book it is 1.1 and in old books it is 1.2 exercise. Question number first. Express each number as a product of its prime factor, that is 140. So we have to factorize 140. Here 140 is ends with the even number, that is 0. So divisible by 2, we get 70. 70 is also ends with the even number, that is 0. So we divide 70 by 2 and we get 35, and factor for 35 is 5, that is 7, and 7 is a prime number, so it is divisible by itself. Now factors for 140 equal 2 multiply 5 multiply 7. We can also express it as 2 की power 2, 5 की power 1 and 7 की power 1. Now we have to factorize 156. Here you can see 156 ends with an even number, that is 6. So divisible by 2, we get 78, and 78 also ends with the even number, that is 8. So further divide by 2, we get 39. Now 39 is an odd number, so ends with the odd digit, that is the number 9. So it is divisible by 3, we get 13, and 13 is a prime number divisible by itself. So factors for 156 are 2 multiply 2 multiply 3 and multiply 13. We can also write it as 2 की power 2, 3 की power 1 and 13 की power 1. Question number first, part C. 3825 we have to factorize. 3825. Here first we have to check the numbers, that is odd or even. Now this number is odd because ends with the number 5, which is an odd number. So first we check the divisibility by 3. So here add all these digits, 18. We get 18, and we know 18 is divisible by 3, we get 6. So this number is divisible by 3. Now we get 1275. So it is also an odd number because ends with the number 5, which is an odd number. Check the divisibility by 3. That is 1 plus 2 plus 7 plus 5. Here we get 15. As we know, 15 is easily divisible by 3. We get 5. So we divide it by 3 and we get 425. Now 425 is also an odd number. So further check the divisibility by 3. That is 4 plus 2 plus 5. It is a divisibility rule for 3. No? Here we get 11. So 11 is not divisible by 3. 11 is not divisible by 3. So we have to divide it by 5. We divide 425 by 5 because according to the divisibility rule of 5, the number must be end with 0 or 5. Here end digit is 5. So it is divisible by 5, not by 3. Get 85. Now 85 also ends with the 5. So further divisible by 5, we get 17. And 17 is a prime number. So it is divisible by itself. Now 3825 factors are 3 multiply 3 multiply 5 multiply 5 and multiply 17. That is, we can write 3 की power 2, 5 to the power 2 and 17 to the power 1. 3825 we have to factorize. First of all, we check the given number, either it is odd or even. Here given number is odd because end with the 5, which is an odd number. So first check the divisibility rule by 3. Sum all the digits of this number and we get 18. As we know, 18 is divisible by 3. So we divide it by 3 and we get 1275. Now further check the divisibility by 3. By sum all the digits of this number, we get 15 and 15 is divisible by 3. So further divide this number by 3. We get 425. Now 425, check divisibility rule for 3. We get 11 and 11 is not divisible by 3. So we divide it by 5 because according to the divisibility rule of 5, end digit must be 0 or 5. Here end digit is 5, so it is divisible by 5. We get 85. In 85 also end digit is 5. So further divisible by 5, we get 17. And 17 is a prime number which is divisible by itself. 3 की power 2, 5 की power 2 and 17 की power 1 as its factors. Now let us solving part D. Here we have to factorize 5005. Now this number is end with the 5. So it is divisible by 5. We get 1001. Now this number is divisible by 7. And we get 143. This number is divisible by 11. Then we get 13. And 13 is a prime number, so divisible by itself. So the factors for 5005 are 5 multiply 7 multiply 11 and multiply 13. We have to factorize part E, that is 7429. So 7429, this number is odd and it is not divisible by 3, not by 5, not by 7. It is divisible by 17 and we get 437. And 437 is also an odd number which is divisible by 19 and we get 23, and 23 is a prime number. So we divide 23 by 23, we get 1. So the factors for 7429 are 17 multiply 19 multiply 23. Solving question number 2. Find the LCM and HCF of the following pairs of integer and verify that LCM product HCF equal to product of the two numbers. So here given number are 26 and 91. So first we have to find their factors and then find LCM and HCF value, and then we have to verify the answers. We have to factorize 26. 26 is an even number because with 6, which is an even number, so divisible by 2, and 13 is a prime number which is divisible by itself. Now we have to factorize 91. So 91 is an odd number because end with an odd digit, that is 1. So first we have to check the divisibility by 3. Sum all the digit, we get 10, and 10 is not divisible by 3. So this number is not divisible by 3. Now we have to check divisibility by 5. Not divisible by 5 because end digit is not 0 or 5. Now we have to check the divisibility by 7. So in 7, last digit that is 1, we have to multiply 1 by 2, we get 2, and from the remaining digit that is 9, we subtract this 2, we get 7, and here 7 divisible by 7, we get 1. So this number is divisible by 7 and we get 13. As 13 is a prime number, so divisible by itself. So we have factorized 26 as well as 91. Now, factor for 26, 2 multiply 13. Factor for 91, 7 multiply 13. Here we have to find the SCF first. So SCF is the number which is common in the factors of the given number. So 13 is the SCF of 26 and 91. Now we have to find LCM of 26 and 91. For finding the LCM, let us take 2 multiply 13. We have to take the factor of any number. We take 2 multiply 13 factors of 26. Now in the factors of 91, we have to choose that number which is not included in these numbers. So here 7 and 13 are present. 13 is already here. So 7 we have to multiply. And finding their product, we get 182 is the LCM for 26 and 91. Now we have to verify the LCM and SCF. For verification, we have formula that is LCM product SCF is equals to the product of two numbers. Let A and B, A is 26 and B is 91. LCM is 182 multiply SCF, that is 13. And here 26 multiply 91. Producting 182 and 13, we get 2366. Here on producting 26 and 91, we get 2366. So the given relation is verified. It shows that the LCM and SCF are correct. So here we factorize 26 and 91. Then we find the SCF. SCF is that number in the factors which is common in the factors of the given numbers. Now finding the LCM, we have to write factors of any number. We write 2 and multiply 13. In 91 factors are 7 and 13. So we have to multiply that number which is not included in this. So 13 is already present. So we have to multiply the 7 and we get 182 LCM. Next we verify the relation and we get 2366. Solving question second part B. Here we have to find LCM and SCF for 510 and 92 and then verify their relation. 510. We have to factorize this number. Here 0 is an even number, so it is divisible by 2 and we get 200. Now 255 is an odd number because ending with the digit 5. So we have to check divisibility by 3, that is 2 plus 5 and we get 12, and 12 is divisible by 3. So yes, it is divisible by 3 and we get 85. Now check the divisibility by 85 for 3. We get 13 and 13 is not divisible by 3. So this number is not divisible by 3 now. So we have to divide it by 5 because end digit is 5 and we get 17, and 17 is a prime number which is divisible by itself. 510 is an even number because ending with the unit digit 0. So first we divide it by 2 and we get 255. Now check the divisibility by 55 for 3. We get 12 which is divisible by 3. So yes, it is divisible by 3. We get 85. Now check divisibility of 85 by 3. We get 13. So this number is not divisible by 13. So we have to divide it by 5. We get 17. And 17 is a prime number which is divisible by itself. We have to factorize 92. Here 92 is an even number because unit digit is even. So we have to divide it by 2 and we get 46. Now 46 is also an even number because end digit is 6. So further divide by 2, we get 23. And 23 is a prime number which is divisible by itself. So the factors for 510 are 2 multiply 3 multiply 5 multiply 17. And factors for 92 are 2 multiply 2 and multiply 23. So for finding the SCF, we have to choose the number which is common in factors of the two numbers. Here 2 is common, so 2 is the SCF. Now we have to find the LCM. For finding the LCM, we have to write the factors of any given number. So here we write 2 multiply 3 multiply 5 multiply 17. That is factors of 510. Now in the factors of 92, we have to choose that number which is not included here. So 2 is present here. Next 2. 2 is present only 1. So we have to multiply it by 2. Now 23 is not included here. So we have to multiply it by 23. And on producting these numbers, we get 23,460. So now we have to verify the relation. For verify, we have the formula, that is LCM, product of SCM is equals to product of two numbers. Here let A is 510 and B is 92. So 510 multiply 92, LCM, that is 23,460 multiplied by 2. Here we get 46,920. Here left hand side is equals to the right hand side. So the LCM and SCF are correct here. In this question we factorize 510 and 92. On factors we find SCF which is common in the factors of both the number, that is 2. For finding the LCM, we take the factors of any one number, that is 510, and in the 92 factor we choose that numbers which are not included in the factors of 510, that is 2 and 23. Apply here 2 and 23 and overall product we get 23,460. Next we verify the relation by applying the formula and we get 46,920 on both sides, that is left hand side is equals to the right hand side. Let us solving question number 2, part C. Here we have to factorize the numbers, finding their LCM, SCF and then verify the relation. So first we factorize 336. Here 336 is an even number because end digit is 6. So we have to divide it by 2 and we get 168. Now 168 is also an even number because end digit is 8. So further dividing it by 2 and we get 84. Now 84 is also an even number because end digit is 4. So divisible by 2 we get 42. Now 42 is also an even number because end digit is 2. So further divide by 2 we get 21. Now 21 is an odd number and we know that 21 is divisible by 3. So we get 7 and 7 is a prime number which is divisible by itself. Factorize 54. 54 is an even number because end digit is 4. So we have to divide it by 2 and we get 27. Now 27 is an odd number which is divisible by 3. We get 9. 9 is also an odd number which is divisible by 3 and 3 is a prime number divisible by itself. So here factors for 336 are 2 multiply 2 multiply 2 multiply 2, 3 multiply 7. And factors for 54 are 2 multiply 3 multiply 3 multiply 3. SCF of 336 and 54, the numbers which are common in the factors of both number. So here 2 is common as well as 3 is common. So 2 multiply 3 we get SCF, that is 6. We have to write the factors for any number. We have write factors for 336, that is 2 multiply 2 multiply 2 multiply 2 multiply 3 and multiply 7. Now in the factors of 54 we have to write the numbers which are not included in this. 2 already present. 3 times 3. Here 3 is only 1. So we have to multiply it by 3 and 3. So the product of all these numbers 3024. So LCM for 336 and 54 is 3024. Now we have to verify the relation. By formula, LCM multiply SCF is equals to product of two numbers, that is A and B. Let A is 336 and B is 54. LCM is 3024 multiply SCF, that is 6. A is 336 multiply 54. The product of these numbers we get 18,144. Similar here 18,144. So here left hand side is equals to the right hand side. So the answers for SCF and LCM are correct. Here we have factorized 336 and 54. On factorizing, we get their LCM, which is 6, and finding their LCM, that is 3024, and then verify the relation. Let us solving question number 3rd. Find the LCM and SCF of the following integers by applying prime factorization method. Here given terms are 12, 15 and 21. We have to find the LCM and SCF of these numbers. First we factorize 12. 12 is an even number divisible by 2. We get 6. 6 is an even number which is also divisible by 2. We get 3. 3 is an odd number which is divisible by itself. Now factorizing 15. 15 is an odd number which is divisible by 3. We get 5. Number and prime also. So it is divisible by itself. Now 21. 21 is an odd number divisible by 3. We get 7. 7 is a prime number divisible by itself. So here factors for 12 are 2 multiply 2 multiply 3, and factors for 15 3 multiply 5, and factors for 21 3 multiply 7. So here SCF of 12, 15 and 21 is the number which is common in the factors of all the numbers, that is 12, 15 and 21. So here 3. 3 is the only number which is common. So SCF is 3. Now we have to find the LCM. So first we write the factors for 12. That is 2 multiply 2 multiply 3. Now we have to take the number which is not included in this from 15 and 21 factors. Here 3 is present. 5 we have to multiply. 3 already present. 7 we have to multiply it by 7. So here we get the product 420 is the LCM of 12, 15 and 21. Solving question number 3rd part B. Here we have to find LCM and SCF. So first we factor for 17. 17 is a prime number divisible by itself. So it is this. Now 23 is also a prime number divisible by itself. 29 is also a prime number divisible by itself. Factors for 17 is 1 multiply 17. Factors for 23 is 1 multiply 23. Factors for 29, 1 multiply 29. SCF of 17, 23 and 29 is 1 because 1 is common only. Now we have to find the LCM. So for finding the LCM, we have to multiply 17, 23 and 29 and we get 11,339 LCM for 17, 23 and 29. So in this question, all the given 3 digits, that is 17, 23 and 29 are prime number which are divisible by itself. So the common number is only 1. So SCF is 1. We have to find the LCM. We just only product the given numbers and we find 11,339. We have to solve question number 3rd part C. Here we also have to find LCM and SCF for 8, 9 and 25. So first we factorize the 8. 8 is an even number which is divisible by 2. We get 4. 4 is also an even number divisible by 2. We get 2. 2 is a prime number divisible by itself. Now 9. 9 is an odd number divisible by 3. 3 is an odd number and prime also, so divisible by itself. Now 25. 25 is divisible by 5. We get 5. 5 is a prime number divisible by itself. So the factors for 8, 2 multiply 2 multiply 2 and 9 factors are 3 multiply 3. 25 factors are 5 multiply 5. We have to find the SCF. Here we have to find the common numbers. We have to write SCF, that is 1. When the common number is not present in the factors of the given numbers, then the SCF is only 1. Now we have to find the LCM. For finding the LCM, we have to write the factors of any number. Let it is 8, that is 2 multiply 2. Now in the factors of 9 and 25, we have to choose the number which is not included in the factors of 8. 3 and 3 not present, so we have to multiply 3 and 3 also. 5 and 5 also not present, so we have to multiply 5 and 5. On producting all these numbers, we get 72 multiply 25, that that is 1800 LCM for this question. Solving question number 4. Given that SCF 306, 657, 9. Find LCM of 306 and 657. So here SCF is given, that is 9. We have to find the LCM value. First number, that is A, is given 306 and second number, that is B, is given 657. So we have to apply the formula which we use for verification, that is LCM multiply SCF is equals to product of both the numbers. We have to find the LCM. So here A product B divisible by SCF. We take this SCF in the divide of A and B product. Putting the value for A, that is 306, B value 657, divide by SCF, that is 9. Now cancel 657 by 9, we get 73. Now we have to multiply 306 by 73. We get 22,338 LCM for this question. SF is given 9. We have to find the LCM. First number is given 306, second 657. So we use the formula which we use for verification, that is LCM product SCF is equals to product of the two numbers. Here we take this SCF in the denominator of A and B product, putting their value, divide 657 by 9, we get 73. Producting 306 by 73, we get 22,338 LCM for this question. Question number 5. Check whether 6 की power n can end with the digit 0 for any natural number n. Here it is given that 6 की power n. We have to find the value for n where this digit is end with the 0. On factorizing 6, we get 2 and 3. Factors for 6 are 2 and 3. So we can say that in the factors of 6, there are only 2 and 3. And 0 digit is not possible for 6 की power n, because for ending the digit with 0, 5 must be in the factors of the number. It is not possible for any value for n where 6 की power n is end with the 0 digit. It is here 6 की power n will end with 0 if 5 is one of the prime of the 6. If 5 is a number in the factors of the 6, it is possible. But prime factors of 6 are 2 and 3. Since 5 is not the prime factor of 6, therefore 6 की power n cannot end with the digit 0. So the condition for ending the digit with the 0 is that 5 must be the factors of it. But here 5 is not present in the factors of 6, so it is not possible for any value that 6 की power n end with the 0 digit. Solving question number 6. Explain why 7 multiply 11 multiply 13 plus 13 and 7 multiply 6 multiply 5 multiply 4 multiply 3 multiply 2 multiply 1 plus 5 are composite number. We have to prove why these numbers are composite. So we have to find their factor. As we know, composite numbers are the numbers which have more than 2 factors. Let us take the values 7 multiply 11 multiply 13 plus 13. Let us take the brackets. Here in this bracket 13, in this bracket also 13. So take 13 common and we get 7 multiply 11 plus 1. 177 plus 1 and we get 13 multiply 78. We can also factorize 78 as 78 is an even number, so divisible by 2, and we get 39. 39 is an odd number, divisible by 3. We get 13 and 13 is a prime number, divisible by itself. So here we can write 78 as 2 multiply 3 multiply 13. Here 1, 2, 3, 13 are the factors for given 7 multiply 11 multiply 13 plus 13. Hence it is a composite number. Now we have to prove this number is a composite number. So here let us take 7 multiply 6 multiply 5 multiply 4 multiply 3 multiply 2 multiply 1 plus 5. Take into bracket. Here we get 5 and 5. So we take 5 common and we get 7 multiply 6 multiply 4 multiply 3 multiply 2 multiply 1 plus 1. 1 for this 5 because it is common here. Now on finding their product we get 1008 and 1008 plus 1 we get 1009 multiply 5. So here 5 and 1009 are the factors for given numbers. Hence 7 multiply 6 multiply 5 multiply 4 multiply 3 multiply 2 multiply 1 plus 5 is a composite number. Solving question number 7. There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? Here is a circular path. In this circular path, Sonia takes 18 minutes and Ravi takes 12 minutes. Both start at the same point, same time and in the same direction. We have to find in how many minutes they meet again at the starting point. We have to find in how many minutes they meet again at the starting point. So here we have to find LCM 18 and 12. Here factorize 18, we get 2 multiply 3 and multiply 3. Now factorizing 12, we get 2 multiply 2 and multiply 3. So factors for 18 are 2 multiply 3 and multiply 3, and factors for 12 are 2 multiply 2 and multiply 3. We have to find the LCM. LCM for this, we have to take the factors for 18, that is 2 multiply 3 and multiply 3. Now we have to take the number which is not included in this. Here 2 is an extra, so we have to multiply it by 2 here. Then we get 36 minutes. So after 36 minutes they meet again at the starting point. Example 5 from NCERT book. Consider the number 4 की power n where n is a natural number. Check whether there is any value of n for which 4 की power n ends with the digit 0. So here 4 की power n is given. We have to find value for n where this digit ends with the 0. So we have to factorize 4. On factorizing 4, we get 2 multiply 2. And for ending the digit with the 0, factors must have 5. So here 5 is not present, so it is not possible for any value of n that this digit end with the 0. Here for the number 4 की power n to end with the digit 0, for any natural number n, it should be divisible by 5. This means that prime factorization of 4 की power n should contain prime number 5. But it is not possible because 4 की power n is equals to 2 की power 2n. That is, it is the factors of 2 only. So 2 is only prime factorization of 4 की power n. Since 5 is not present in the prime factorization, so there is no natural number n for which 4 की power n ends with the digit 0. Here we simply factorize 4, we get 2 as the factor of 4. And for ending the digit with the 0, 5 must be present in the factor. Here 5 is not included in the factors of 4, so it is not possible for any value of n that 4 की power n ends with the 0 digit. Solving example 6 of NCERT. Find the LCM and HCF of 6 and 20 by prime factorization method. We have to factorize 6, we get 2 and 3. as its factor. Now we factorize 20. 20 is an even number, so divisible by 2 we get 10. 10 is also even number, divisible by 2 we get 5. 5 is a prime number, divisible by itself. So factors for 6 are 2 and 3, and factors for 20 are 2 multiply 2 multiply 5. Now we have to find the SCF. So SCF is the number which is common in the factors of given number. Here 2 is the only number which is common. So SCF is the 2. Now we have to find the LCM. Let us take factors for 6, that is 2 multiply 3. Now we have to multiply the number which is not included in this. 2 is present 2 times, but 2 is only 1. So we have to multiply 2. Now it is 5. 5 is not included in it. So we have to multiply it by 5. Now the product of all these numbers is 60. So LCM for 6 and 20 is 60. Here we have to find LCM and SCF for 6 and 20. So first factorize 6 and 20 and we get 2 is a common number. So 2 is the SCF for 6 and 20. Next we have to find the LCM. So we take the factors for 6, that is 2 and 3. In the factors of 20, we have to put out that number which are not included in the factors of 6. Here 1, 2 and 1, 5 are not included in the factor of 6. So we multiply 2 and 5 here and we get overall 60 LCM. Solving example 7 of NCERT. Find SCF of 96 and 404 by prime factorization method. Hence find their LCM. Here we have to find SCF for 96 and 404 and then their LCM. So first we have to factorize 96. 96 is an even number. So divisible by 2 we get 48. 48 is an even number. Divisible by 2 we get 24. 24 is also an even number. Divisible by 2 we get 12. 12 is also an even number. Divisible by 2 we get 6. 6 is also an even number. Divisible by 2 we get 3. 3 is divisible by itself. Now we have to factorize 404. 404 is an even number. Divisible by 2 we get 202. Now 202 is also an even number. Divisible by 2 we get 101. 101 is a prime number, divisible by itself. Now factors for 96. 2 multiply 2 multiply 2 multiply 2 multiply 2 and multiply 3. Factors for 404. 2 multiply 2 multiply 101. Now we have to find out SCF. So SCF is the number which is common in the factors of both the number. So here 2 and 2. 2 times 2 common, that is 4. 4 is the SCF. Now we have to find the LCM. So we write the factors for 96, that is 2 multiply 2 multiply 2 multiply 3. Now we have to write the number which is not included in the factor of 96 from the factors of 404. That is 2 times 2 already present. 101 is not present here. So the product of all these numbers is 96 multiply 101. 96 and 101 we get 9696 LCM for this. So here we factorize 96 and 404. From the factors we take out the common number, that is 2 times 2 we get 4 SCF, and on finding the LCM we take out the factors of 96 and take the number from 404 factors which is not including 96, that is 101. Multiplying all these numbers we get 9696 LCM. Solving example 8. Find the SCF and LCM of 6, 72 and 120 using prime factorization method. So we have to factorize 6, we get 2 multiply 3. Now we have to factorize 72. 72 is an even number. Divisible by 2 we get 36. 36 also even number. Divisible by 2 we get 18. 18 is also even number. Divisible by 2 we get 9. 9 is divisible by 3. We get 1 here. Now we have to factorize 120. 120 is an even number. Divisible by 2 we get 60. 60 further divide by 2 we get 30. 30 divided by 2 15. And 15 divisible by 3 we get 5. 5 is a prime number divisible by itself. Here factors for 6, 2 multiply 3. Factors for 72, 2 multiply 2 multiply 2 multiply 3 and multiply 3. factors for 120, 2 multiply 2 multiply 2 multiply 3 and multiply 5. We have to find the HCF. For finding the HCF, we have to take out the common number from the factors of these number, that is 2, 2, 2, 3, 3 and 3. So 1 time 2 and 1 time 3 is common, so we get overall 6 HCF. Now we have to find the LCM. For finding the LCM, we write the factors for 72, that is 2 multiply 2 multiply 2 multiply 3 and multiply 3. Now in the factors of 120, we have to choose that number which is not included in the factor of 72. That is 3 times 2 already present, 3 already, 5 is not here, so we have to multiply it by 5. In the factor of 6, 2 and 3 are present, here 2 and 3 already present. So now on producing all these numbers, we get 360 LCM for 6, 72 and 120. So in this question, we first factorize 6, 72 and 120. Then finding their HCF, we get 6, and finding their LCM, we get 360.